Problem 4 and 5 ask me to look at the graphs that are given and state whether or not each of the graphs are a function. And then it wants me to list out the domain and range. So let's start with number 4. When I'm looking at a graph and I'm trying to determine whether or not it's a function, what I want to use is the vertical line test. I can draw vertical lines at any point on the graph, and as long as the vertical line does not cross the graph in more than one spot, I have a function. Notice that number 4 passes the vertical line test, and so in this case, I would say that yes, in fact, this is a function. Then at that point, I'm going to need to determine my domain and my range for this function. I like to do this by drawing a box around the function, but you can also do it by going ahead and just looking at the points on either end for the domain. This doesn't necessarily always work for the range, as we'll see in a second. We're going to use set builder notation. We'll write our bracket, an X, and a vertical line. So that is the set of all X such that X is equal to, and then I'm going to list out my domain. Now in this particular case, I draw my box. Remember, by the way, that those are open circles at the end of my function. And the box allows me to see very clearly what the farthest place on the graph is on the left-hand side and how far the graph goes on the right-hand side, as well as top and bottom. In this case, I'm going to notice that the farthest it goes to the left is a -3, and I will write that. I have an open circle here. Open circle is not included, so I do not write an equal to line underneath my inequality symbol. I write an X, and then I write another less than symbol. Remember that that point on the far right-hand side of the box, that is also an open circle, so I still won't write an equal bar underneath my inequality, and that is a 4. And so that's it. I'm done. My domain is -3 is less than or equal to is less than X, and is less than 4. For my range, I'll do the same thing except with Y. My domain are my X values, my range are my Y values. Now, in this particular case, my lowest possible range value is lower than where the dots are located. It's there at -3. And that is a solid line that is going through -3. So that is less than or equal to, and then I have to write Y. Now I'll look at the very topmost value. And in doing that, I'm going to realize that that is a 5. But that is an open circle, and the open circle is the highest point. So that is not going to have an equal to line underneath. And so that will be my range. -3 is less than or equal to Y, which is less than, but not less than or equal to 5. And that's my range for problem number 4. Looking at problem 5, problem 4 was a continuous graph. Problem 5 is a discrete graph. Discrete means it's just a collection of points on a graph. There is not a line connecting these points. If I have a line, I have a continuous function. But I can still run my vertical line test. And when I run my vertical line right there, it goes through 2 different points. That means that I have an X value that points to 2 different Y values. I can't have that if I'm going to have a function, so I know that this is not a graph of a function. But I can still list the domain and the range. In this case, what I would advise you to do is to label each of these points so that you know which point is represented in each particular spot of this graph. I'm going to set up my set builder notation. This is the set, my set builder notation. This is the set of all X such that X is going to be equal to, notice here, I have X as a -4. So that's -4, comma, -5. It's the point that I have in question there. My next point is -2, 0. My next point is the origin, 0, 0. After that, I have 3, 2. And just above 3, 2, I have 3, 4. That's the reason this is not a function. And then finally, 5, 4. Now I just need the x values from each of those. -4, -2, 0, 3, which I only have to list one time. I don't have to write both instances of 3. Writing it once is sufficient. And 5. And that's my domain. Notice on a discrete function, I list the specific x values, whereas on a continuous function, I have to list between this number and this number, correct? Now my range values. In this particular case, I will do the set of all y such that, and then I list my y values, -5, 0. Notice I don't have to write 0 twice. 2, 4. Notice I don't have to write 4 twice. And now I am completed my range and my domain, and I've determined that this is not a function. Now let's take a look at number 6, 7, and 8. I want to determine whether each of these various relations is a function or not. If it's not, I need to explain why not. Notice that if it is a function, I'm not asked by the question to explain why it is a function. Something to keep in mind as we look at these. So looking at number 6, that's a graph, and well, this graph is going to really flunk the vertical line test, isn't it? 1, 2, 3 different places that this same vertical line intersects this graph, and they are listed for you there. Well, that can't happen, so this is not a function. And the reason is because it fails the vertical line test. So that's the sentence I'd write. No, because it fails the vertical line test. Number 7. Number 7, I don't have a graph, so I can't do a vertical line test, but I can't have repeating x values. Whether this is a set of ordered pairs, whether this is a mapping, whether this is a table, I need to look for repeating x values. In this case, I don't have them. 5 and -5 are not the same number. None of these x values repeat. It's okay that I have repeating y values. I cannot have repeating x values. So in this case, yes, this relation is, in fact, a function. On number 8, I have a mapping, and I have a similar situation here. I simply can't have an x value that is pointing towards more than one y value. But I don't. I have one arrow coming from each particular value of x. It's okay that 0 and 1 in my x column point towards the same y value. That's okay. What I can't have happen is that I cannot have, say, -8 pointing towards a -1 and then also pointing towards another value. Since there's only one arrow that is emanating from each x value in the mapping, that's going to be okay. This is a function. Now notice if I had 2 arrows coming from -8, one going to -1 and one going to 4, that wouldn't work. But that's not the case. And so I do have